So far, we've been talking about data that comes from one source, people walking out of a cupcake shop, or flight delays in New York, or wedding spending by readers of a popular online magazine. But sometimes we want to make comparisons between two data sources. We want to know if one cupcake shop has different ratings than another, or if flight delays differ by airport. Let's look at how we might do this using the intuitions about data distributions that we've been building. So I'm going to introduce to you two types of penguins. These are the Adelie and the Gentoo penguins, and these are two species that live in Antarctica. And perhaps we are interested in understanding something about how big they are. So here's a distribution again. And a distribution, remember, is, we've perhaps weighed a whole bunch of penguins, and these are all Adelie penguins. And so we took all of their weights and we've put them on this plot here. And so we can see a couple of things about it. First, we're looking at their body mass. So body mass is on the x-axis here. So this axis here is body mass going from smallest to largest. We have the count, so that's how many penguins there were of a given body mass. We have some plausible range. Looking at how far the body masses span, we can see that the penguins are between about 2,500 and 5,000 grams. And we could try to guess what's a plausible mean. So looking at this distribution, it's pretty symmetric. So I'm going to say we can just use the mean to estimate something about the peak. And it looks like it's around 3,700 grams. So we could draw a line right about here. Now let's take a look at data from the other species, the Gentoo penguin. So look again, we have the width of this range. So the penguins seem like they span from about 4,000 to 6,000 grams. There's a peak that is about at 5,000 grams. And finally, we can look at them together. So if we were to plot these two distributions on the same graph, we can see in one color, we've got the Adelie. In the blue color, we've got the Gentoo. And this region where it's darker, that's where they overlap. So let's ask a question. Which penguin species is larger? Think about this question. Because each penguin species can have a range of body masses, maybe we should ask, does a typical Adelie penguin have a bigger or smaller mass than a typical Gentoo penguin? And one way to quickly summarize what's typical in this case would be the mean body mass for each species. And we know the mean is a pretty useful summary in this case because these are nice and roughly symmetrical distributions. They don't have very long tails. So our plan then is actually to answer this question. We can estimate the mean of each of the two penguin species and then compare which mean is bigger. So let's go back to our histograms and start labeling. Let's first label the average body mass of the Adelie penguins. It's right here. And let's do the same for the Gentoo penguins, right here. So looking at these two, we could say that the Gentoo penguin's body mass is, on average, larger than the Adelie penguins. But what does it really mean for one species to be larger on average? I want to add some nuance here to what it means to compare averages. True or false? Think about this. Does this mean that every Gentoo penguin is bigger than every Adelie penguin? Look at the graph for a moment and see if you can get any intuition, any hints that are calling out to you. Is every Gentoo penguin bigger than every Adelie penguin? Now, the biggest Adelie penguin is close to 5,000 grams. We can see that because of in the distribution of Adelie penguins, we've got some data that's over there right around 5,000 grams. And let's look at the smallest Gentoo penguin. So if we look at their data distribution, where's the tiniest penguin? Right about there. This one's a little less than 4,000 grams. So when we see them on the same picture, we can be sure that there are indeed some Adelie penguins that are bigger than some Gentoo penguins, even though Gentoo penguins are on average larger. Another way of seeing this is that there is an overlap between the distributions. Penguins of both species have been observed in this range here that I've darkened, in this range of body masses. So what does it really mean to be bigger on average? Well, we've decided that this is, in fact, false. It is simply not true that every Gentoo penguin is bigger than every Adelie penguin. So does it even really matter that we found out that Gentoo penguins have a bigger average body mass? Well, I'd say yes, and here's two ways of thinking about why. One way we could say it is that a typical Gentoo penguin has more body mass than a typical Adelie penguin. So we're saying something about typical. We're saying that, there's something about, where those penguin body masses cluster, and it's in a slightly different place for each species. So another way of saying that is if I were to randomly pick an Adelie penguin and a Gentoo penguin, usually, more often than not, the Gentoo penguin would have a higher body mass. Comparing the means of two data distributions is a useful way to identify some bigger patterns, like that Gentoo penguins tend to have more mass than Adelie penguins. And using averages helps us create expectations, or general ways of simplifying data so that we can think about it. Sometimes those will be wrong, like when we find an especially small Gentoo penguin or an especially large Adelie. But we have still learned something that works in more cases than it fails. Here's a central tension in statistical thinking. We can learn to identify patterns that hold in some cases, maybe even a lot of cases, but we will rarely talk in absolutes. Being right about statistics means expecting to be wrong some of the time.